Hi friends, many a time it is required to obtain the Fourier expansion of a function f of x for the interval 0 to L, which is half the period of the Fourier series. In such cases, we will extend the function fx in the interval whose range is L to L, so that we can expand it like our Fourier series of length 2L, whose interval will be of length 2L. Fine. Now, if this is your origin, this is our L. Suppose this here at some point there is a L. Similarly, here this is minus L. And even on the other figure, I can assume that central point is 0. As we know, this is L. Now this is minus L. As we know, it is immaterial that whatever the function may be outside the range 0 to L. Now question is how we can extend the function. If this is our y-axis, this is our x-axis, again here y-axis and this is our x-axis. We can extend the function f of x outside the interval. Which interval? 0 to L, in such a way that either it is symmetrical about y-axis or it is symmetrical about origin. In case if it becomes symmetrical about y-axis, then this function will be called even function. And in case its extension is symmetrical about origin, then we say the function is our odd function. Fine. Now what's the other way to check even or odd? Already we did in the concept of even and odd function that if f of minus x is equal to f of x, then I will say function is even function. And in case f of minus x is equal to minus of f of x, then we say function is our odd function. Fine. Now in case my requirement is to expand the function half range as a half range sine series. Sine series means a0 and an are missing. In such case, I will extend the function f of x from the range 0 to L to minus L to L in such a way that it becomes symmetrical about origin. That is, it becomes odd function. Means I will extend the function in such a way that f of minus x becomes equal to minus time f of x. Then in such case, I will get the sine series. Once I have extended the function from the interval 0 to L to minus L to L in such a way that f of minus x is equal to minus f of x, I can apply the concept of odd function. That is, I will extend the function f of x in the interval minus L to L when fx is odd. If fx is odd, then which terms are 0? a0 is 0 and an is 0. These two terms are 0. If these two terms are 0, then we can write the Fourier series of the function f of x in the interval minus L to L as, how we can write, 0, sorry, this is 1 to infinity bn sine of n pi x by L, where what is bn? Bn is 2 by L 0 to L f of x sine of n pi x by L. This is our dx. Fine. This series, this series, this series, this is called our half range Fourier sine series. In case we wish to write the cosine series, then I will extend the function in such a way that it becomes symmetrical about y-axis. That is f of minus x is equal to minus f of x. If it is f of x minus x is equal to plus f of x, that is function is even, then we can write the expansion of the function for the interval this, when fx is even, it includes only a naught by 2 plus summation n varies from 1 to infinity a n cos of n pi x by L. In such cases, Bn is equal to 0. Where a naught is given by, like we have written for even function for the interval minus L to L. Here, similarly, I will write a naught as equal to 2 by L. This is 0 to L. Fx dx, and an is 2 by L, 0 to L, f of x cos of n pi x by L dx. Fine. This is our half range cosine series. We need to remember these two formulas to express the function as a half range sine series or cosine series. The express function f of x, which is given to be x, as a half range sine series in the interval 0 to 2. Now see, when it is mentioned that f of x needs to be extended as a half range sine series, it means our extension is in such a way that the function is becoming symmetrical about origin. That is, our function is odd function. Now even if you will verify here the nature of f of x, this is given to be our odd function, and it is asked that I should write it as a sine series. When I need to write it as a sine series, then in this case I need to calculate firstly I need to calculate the value of L. What is L? Here interval is 0 to L in journal, and here it is given to be 0 to 2. So what is the value of L here? L here is 2. And if I ask you to write the Fourier series, Fourier which series? Fourier sine series in the interval 0 to 2, we can write the Fourier series as f of x is equal to summation n varies from 1 to infinity. Bn is there. Sine of n pi x, n pi x by L. But here L is 2. I will write here divided by 2. Say this is your number 1. Now to complete the problem, I need to get the value of Bn. Where? How we can find Bn? Bn is 2 by L. General formula is 2 by L. 0 to L. Fx sine of n pi x by L dx. Now here, what is our L? L is 2. So I will write here 2 by 2, that is 1. Integral 0 to 1. Value of x is, fx is x. Sine of n pi x dx. Because L is 2, I should write here 2. Now how we can extend this? We can integrate it by using the formula of u into v. First function as it is x. Integration of second function. Integration of sine is minus cos of n pi x by 2 divided by n pi by 2. Minus derivative of x, which is 1. Again integration of cos. This is minus sine of n pi x by 2 divided by, I will get n square pi square by 2 square. Fine. Lower limit is 0. Upper limit is, what is the value of L? L is 2. Even here I should write 2. Fine. Now see, when we will apply the upper limit, here x, this is 2 into, I may write this as 2 by n pi into cos of n pi 2 by 2. I will get here cos of n pi. Sign is negative. I may place here negative. When I will replace x here, I will get x n pi. 2 by 2, 2 and 2 will cancel out. I will get here n pi. Sine of n pi. Sine of n pi is 0. I should write here 0. This is upper limit. Minus lower limit 0. When you will replace this x by 0, this entire term will become 0. And second, when you will substitute here x as 0, this sign of 0 will give us 0. So on substituting the lower limit, I will get here 0. Fine. So we are left here with minus 4 n pi cos of n pi. And already we have written that cos of n pi is minus 1 raised to power n. Or further you can write it as 4 minus 1 raised to power n plus 1 divided by n pi. Fine. Substituting these values in equation number 1. Substituting Bn in equation number 1, we get f of x is equal to summation 1 to infinity. Bn is 4. I can keep 4 by pi outside the summation. Inside, I will write minus 1 raised to power n plus 1 divided by n into sine of n pi x by 2, which is the required, this is the required Fourier sine series. This is your problem number 1. On the same track, we can expand the same function as a cosine series. Now let us write the same function as a cosine series. Your next problem, your problem is express f of x is equal to x as a half range cosine series in 0 less than x less than 2. Now see here, what is the value of L? If I ask you to write the value of L, L is 2. And what is our cosine series? Half range cosine series. This is a naught by 2 summation n varies from 1 to infinity an cos of n pi x by 2. So this is your number 1, where a naught, this is 2 by L. L is 2, 0 to 2, fx is x dx. So on solving here, see what I will get. This is 4 by 2, that is 2 minus 0. You will get the value of a naught as 2. Now we will get the value of an. Also an is 2 by 2, which is 1, 0 to 2, x cos of n pi x by 2 dx. Again uv, first function as it is, integration of cos is sine of n pi x by 2 divided by n pi by 2. Minus derivative of x is 1. Again integration of sine is minus cos of n pi x by 2 divided by n square pi square by 2 square. Lower limit is 0, upper limit is 2. On substituting, upper limit 2. First term you will get sine of n pi. Sine of n pi is 0. Second term minus minus plus. I can write 2 square by n square pi square. I will get here cos of n pi. Bracket close, minus lower limit. This is 0. When you will replace this x by 0, your entire term, this entire term will become 0. 0 plus 2 square n square pi square, and cos of 0 will give you 1. So here I will get 2 square n square pi square. I can take it common. Inside I will get cos of n pi minus 1. So further I may write 4 by n square pi square inside the bracket minus 1 square minus 1. Substituting the value of a naught, substituting the values of a naught and an in equation number 1, we get f of x. A naught we have got its value as 2. So you will get 2 by 2, that is 1, plus summation an. If I can write 4 by pi square outside the summation because this is independent of n. Inside minus 1 power n, this is n, minus 1 power n minus 1 divided by n square cos of n pi x by L. L here is 2. N is from 1 to infinity, which is required expansion that is cosine half range cosine series. I hope the concept is clear to you all. Thank you. Have a nice day.